On our last part, we focused on getting our file loaded into the program and into the memory of the Chip8 emulator. Now we need to focus on our program cycle and getting our opcode so we can finally start doing some arithmetic. First off, I want to work on fetch opcode, but I'm actually going to move it up a little bit because I know that we need to work on this primarily first. So I will put this above the program cycle so we can get to work on that now. What I'm going to do starting off here is I'm going to put a bounds check. So I'll just comment this so you all are aware. If CPU program counter is greater than FFE, we'll write an error out into the stream that says warning program counter out of bounds. Now you may be wondering why I'm just doing a warning here, and the reason I'm doing that is because as we write our arithmetic, we may run into bugs that we didn't anticipate. And if we start seeing this error being spit out multiple times, then it is likely that we have an error with our code and not our actual ROM file itself. So rather than putting error handling in to shut off the program right now, I want to make sure everything is working properly, and then we can add our error handling once we have everything implemented. For now, this will work and it will detect whenever the program counter goes out of bounds. Now you may be also wondering, why are we doing it at hex FFE and not hex FFF? The reason for that is because, and I have it out here on the right, every Chip8 opcode is 2 bytes. So when we read from FFE, we're actually reading from 2 locations. We're reading FFE and FFF, so they come together in a big Indian style as one opcode. Let's go ahead and write the rest of our function. We're going to declare a 16-bit unsigned integer, and this is going to be our actual opcode. Here we will take the memory from the CPU and we will load the value located at the program counter. And because this is a big endian architecture, the first bit that we loaded is going to be on the high side. So we need to bit shift this left by 8. And we can OR it so we can get the next half. What we're doing here is we're going to be reading the next part in memory, which is just us taking the program counter and adding +1 to it within the actual array itself. Do not increment program counter here, so make sure you're not putting this. Do not use ++ here, as it will increment the counter, and we're going to be incrementing the counter in the program cycle by 2, so don't do it here. Just do a +1 so the program counter value stays the same unmodified. Next, I'm going to print out the opcode, and the reason I'm doing this is just for debugging purposes. We can see on our stream what opcodes are being ran and if there's something going on that we're not sure of. And now we can return the opcode, and that's it for this function. I do notice something here on line 71. I did not add a new line, so let's go ahead and do that. The last thing you want is to continuously print things on the same line. You want it to be nice and clean, so make sure to add a new line to the end of that. Now we can start working on our actual program cycle. This function may seem like it's going to be a lot, but it's actually pretty straightforward. But the first thing I'm going to do is I'm going to add a section here, just a comment saying pause logic. So later on, I won't add the logic now, but I'm just going to add a simple if statement. And this just says if halt until pressed, then we return from the function. So this makes it to where the program cycle will never increment. It will just be stuck in a loop until that pause variable equals false. That's why we added it in the CPU before, because it's going to act as a pause or a halt until we press a button. And we'll get the logic for that later. But for right now, I just want to add this in here so you have an idea of what's going on and where we're going to be doing this later on. For the rest of this function, we'll just go ahead and get our opcode. Call it opcode again, fetch opcode, and we will pass our CPU pointer to the fetch opcode function. And then from here, this is where we will increment our actual PC counter. And the reason why it's 2 is because we had to read from 2 addresses, which each one has 8 bits. Combining those two is 16. So because we had to read from 2 locations, we need to increment it by 2. If you increment it by 1, you're going to run into all kinds of weird errors, so make sure you stick with 2. And then last, we could take our execute opcode, pass the CPU pointer, and pass our opcode. What we're going to do now is we're going to skip the execute opcode function, and I'll explain why in a minute. We're going to work on the update timers. The way that I set this up is I put an if statement here. If CPU delay timer is greater than 0, we're going to decrement it. If you have a look on the right here, our delay timer is a timer that counts at 60 Hertz. So for every frame, this counter will decrement until it reaches 0. This timer is used by a lot of ROMs to handle actual timing of events happening. A game can set a duration for these 2 timers, and the way it works is for every tick of the processor, this timer will decrement by 1 until it reaches 0. Make sure to leave this guard at delay timer is greater than 0. If you put it at greater than or equal to 0, it will go down below 0, which will make it wrap around the 255. Then you're going to get all kinds of weird things. So just leave it as this. Lastly, we'll do the same thing for the sound timer. The way the sound timer works is that when it is not 0, it makes a beeping sound. And this is something that we can increment later in STL, which is going to be the window that we're going to be using for this. For execute opcode, I saved this one for last because this is where all of our execution and decoding is going to happen. For every single possible case that we can have for our opcode instruction set, we need to make sure we handle it within this function. There are 35 possible opcodes for the Chip8. So as you can imagine, it's something that we're going to need to split up into multiple parts. We're not going to be able to do all of it within just one part, or the video would be extremely long and it would be hard to follow. So for right now, the only thing I want to do is just pass over the opcode within the function so we can start from there. I added a mask here, and the reason I did that is because we already have the opcode in the parameter, so it's basically still unchanged for when we're going to be using it later. But I added the mask here because we need to take that most significant part of the 16-bit opcode and we need to separate it via that value. Every single opcode, the difference between them starts with that most significant bit, and we can take that within the switch statement and be able to handle every possibility from just starting from there. If this seems a bit confusing to you right now, don't worry. When we start looking at the actual opcodes, things will start to come together and it'll make a bit more sense. For now, just know that we're going to be separating them at first via that F value, which is why we're masking it off at F000. I think here is a good place for us to stop. I want to recap real quick. What we did is with the fetch opcode, we did a bounce check. We made sure to get our opcode, set it up big endian style. We printed out the opcode, we returned it, and in the cycle, we handled our pause logic, at least temporarily. We'll be adding more to that later. We got our opcode from the fetch opcode function. We went to CPU program counter, we incremented that by 2, and then we called our execute opcode. We haven't called our update timers yet. We'll get there, but that's something that we're going to be handling elsewhere. Just know how they work and where the function is located. It'll make sense later on. Thanks guys for coming to this part. If you have any questions, please leave them in the comments below. I'm always willing to answer any questions that you have. I know that this can seem a little bit much, but don't be afraid to ask questions. When it comes to the execute opcode, that's where all of our actual math and arithmetic is going to be done. So please feel free to ask questions and don't be afraid to reach out. Appreciate you guys for coming. Hope to see you in the next part.